Hello everybody. So today Dion is going to teach me a little bit about geolocation with the BlenderBIM model. Hi Dion, how are you doing? Are you ready to teach me?
No, I'm not ready, but we'll give it a shot. So today I'll talk a little bit about geolocation. And the thing about geolocation in IFC is that actually it's super easy, but what's the difficult part is actually understanding the importance of geolocation and what what information you need to be asking for and who you're meant to be asking to make sure that you've recorded everything correctly. And just a disclaimer, I am not a trained surveyor. I was trained as an architect, which means that we don't know a lot of things to do with numbers and geolocation, but I've tried my best, and so if I do make some errors, please excuse me, but this is to the very best of my understanding, and I have spoken with people who do know this topic a lot better than me. The second thing I do want to clarify here is that the topic we'll cover together today is what's called vertical BIM. So basically, that's essentially most of what we're dealing with are individual buildings on a site. So we're not dealing with long roads or highways that cross many kilometers and countries and things like that. So that would be what we would call horizontal BIM. Today we'll just talk about vertical BIM. And horizontal BIM geolocation is much trickier. And the support in IFC is a little bit interesting. So yes. Yeah, we won't get into that. So, short one today. So the first thing to realize, hopefully you can see my screen, I'll delete everything here, is just kind of how complicated the field of geolocation is. Because a lot of you, I assume, have started up a project before, and you've entered in some eastings and northings, and you think you're done, but there's a little bit more to that, which I want to share. So I'm just going to try and explain it by creating this sphere here. So this sphere is going to represent the Earth, and I'm just going to subdivide this one more time and just kind of get a wobbly type shape thing, because that's what the Earth is like. It's a little bit wobbly, and it's also not really a sphere. It's kind of like the squashed type of object thing, which I'm exaggerating. So mathematically, if you want to pinpoint where you are on the world, and that's the whole point of this exercise, is say, where am I? Say, my building is here on the world, and you want to correlate between that point on this kind of rough, uneven, squashed sphere thing to your local coordinate system, which is this X and Y plane here. What processes are involved in that? And I won't have time to go into a huge amount of detail, but I just wanted to briefly describe some of the complexities involved to get a good idea so that then you know why you need to ask this information. So the first thing to do when you're trying to work out where you are on here is generally mathematicians work out a kind of mathematically perfect ellipsoid, which is kind of squashed. So for example, if I created a new sphere here and I kind of squashed it, that kind of approximately represented the true Earth, that would be kind of like the first step that you'd go across. And what you'd do then is you'd say, okay, now I know the center of mass of my Earth, because that's how gravity works, and you have your network of satellites which are kind of orbiting around it and so on. And you kind of just pick an arbitrary point in space, as in like outer space, for example, and say that's my north. Where my north is, and that gives you one axis, and then you pick an arbitrary point. In this case, we have Greenwich, as you know, and that gives you angular measures for longitude and latitude. So that's kind of how longs and lats work. So in theory, you could specify your entire drawings in longs and lats, but that becomes kind of impractical. Largely because longs and lats are, firstly, they're measured in degrees, not in a unit. So generally, what we do is we tend to project a patch of the Earth. So let's say our site is located, X in the middle over there. What would happen is you would project that up onto a plane, and this plane would be a flat 2D grid. Now, I'm simplifying this a little bit. It's not they don't usually project to a plane. They usually project to a cylinder, kind of like this. But for simplicity's sake, they'll do a projection that's similar to this, and that gives you a flat 2D grid, which you have your x-axis, and you can have your y-axis. So you can see there are quite a few steps involved, and the good thing is that in general, we don't need to work these out. That's what surveyors are for, and we just need to kind of ask them to make sure that all of the stuff is well considered. They'll tell us the right projections to be using. But this gives you an idea of one of the things we should be asking. We should say, what type of projection system are we using? And this type of data is one of the pieces of information which should be stored in an IFC. And so, for example, again, in Autodesk for Revit, for example, there is no standardized field for storing that projection data. And so this projection set of methods I'm doing here, if you're just recording an easting and a northing, which is basically the X and Y here, you are not fully geo-referencing your BIM data. You're missing the projection system. And the projection system matters because it's different everywhere in the world. But more than that, it's also different across time. So for example, there's tectonic plate shifting happening all the time. And in the case of where I am, and this little blob here is Australia, and this is New Zealand. We can't forget New Zealand because Duncan's on the call. But essentially, Australia is drifting away from where's Greenwich, somewhere over there, and it's drifting away. And so over time, where we are is actually moving. The longitudes and latitudes are always constantly shifting on every single point on Earth. And so you have to record lots of different pieces of information. You need to record not just the eastings and northings and the height data, which you're all used to. You also need to record the system used for the ellipsoid, the system used for this map projection, the system used, I've lost track. And also the system, when that system was marked in time. So all of that information needs to be stored. It also gets a little bit tricky here because you can see that with a projection, the point I measure here and the distance I measure from here to here is actually not the same as the distance from here to here. You can see because it's curved and the terrain is also a bit wobbly and all that. Even though I have a nice flat grid and I think I'm measuring things out on my on my 0 point, let's say that's my 0 point, and I measure out here X meters, it's actually not X meters. And we can't forget this, that even though we're working on a flat plane, you're measuring things, and it's not necessarily what you measure is not necessarily what it actually is in the world, in real life. But the good news is that we're here talking about vertical BIM and small sites, and generally with vertical BIM and small sites are defined as an area of less than 1 kilometer squared. All this type of complexity can be reduced into a simple 2D transformation, a transformation which says that, okay, here is my 2D grid, which I'm currently working on, and if I offset it in a particular a particular number, if I rotate it a particular number, and then if I scale it slightly a particular amount, it will translate between a coordinate on any coordinate on my local to a coordinate on the globe. So hopefully that was a short summary, and the pieces of information you actually need to store is here in the Scene Properties tab under a IFC georeferencing. So all you have to do is press Has Georeferencing, and you just fill in your eastings, northings, your orthogonal height, and so on. Now, I will run through a quick exercise of this, and hopefully that will just kind of cement it. So in Sydney, the technique we use, MGA coordinates, and the official way to look these things up, and this is for most simple projects. On a complex project, you may have a custom coordinate system, but for most projects, you can refer to your coordinate reference system in on this site, the EPSG site. And this is important because you can't just fill this out as whatever you want. Because let's say your eastings is, I don't know, some really big number. It wouldn't in Australia. This would be something else. It's actually not these numbers, but this is just as an example. I'll talk about abscissa and ordinate. So let's say you filled in your numbers which represent your X and Y and your Z, and abscissa and ordinate represent the rotation. And there is actually a scale factor as well, which I'll skip at the moment. You also need to record your coordinate reference system. So the coordinate reference system, you can't just type in whatever old value. This needs to be something that's taken from a central database. And in that case, that would be from the EPSG dataset. So I will go here. Oh, they have a map search. This is new. That's new. So I guess I can, oh, here we are in Sydney. I guess if I click on a point somewhere in Sydney and I press search, but just in case it doesn't work, I will open up the text search as well. I will find the coordinate system that is used in Australia. And, oh, this one's come up. So the one that was used, it has changed, was this one here, MGA zone 56. And you can see it has a code, 28356. And that's important because that's the code that you need to enter. So in this case, I would enter EPSG, which basically namespaces it to say that that's the database which it comes from. And then it was 28356, yep. So this is the system that is being used, and this is the standard place to store it. Once you've done that, you can fill out the rest of the fields, but you should only fill them in if it's not already covered by the definition here. So descriptions, generally you won't need to fill out if it's already in the EPSG database. So for example, if I click on that, you'll see that it already has a name, so it's already fully described. You can access the well-known text for it up here on the top right, which will give all the extra metadata of it. So this will let you know whether or not that piece of information has been stored or not, and whether or not you need to fill it in your IFC file. So for example, description I don't need to fill in because it's already there. Here it is. The geodetic datum, if I search for, there we go. So this is the geodetic datum, the base GeoCRS. So that's already stored as part of this definition. So I can leave that blank. The vertical datum is not stored in this, so that's something I will need to fill out. So if I go back here, and you can see that there are different projections and CRSs that are used. So if I scroll down, I should find the Australian height datum. AHD height, there we go. So this is the vertical CRS. And so if I find the Australian height datum here, we can see that the code is 5111. And so we just type that in, EPSG 5111. The map projection, if we go back to the CRS and back to the well-known text, the map projection should be under the conversion method here. So it's already being stored. The map zone is also already stored, as in map grid of Australia zone 56. And finally, the unit of this is given over here in meter, but this one you should type in. And so now we've fully recorded all the information about the coordinate reference system. you'll get these numbers from your surveyor. They will also give you the rotation to true north. Don't enter these numbers made up like I am now. You should always get them from your surveyor. And so I'm just going to help people understand what this abscissa and ordinate is, and that's because some BIM programs record they don't let you translate between this and a rotation. So very well. So for example, ArchiCAD is one where you actually need to fill this out manually. So if I just get rid of all of this, sorry, I'm going very fast here, maybe too fast, but I'll try here. This this one effectively describes the rotation that you need to apply to go from your local to your global coordinate. And x-axis abscissa and the x-axis ordinate basically describes where east is, almost. So for example, if north is up the page, therefore that would be your y-axis, and this would be your x-axis, and this can be represented by a coordinate of 1, 0. This is known as the abscissa, and this one is known as the ordinate. So therefore, if north was exactly up the page, you would put here 1 and 0. The scale factor is something that your surveyor will tell you. Now, if your north was here instead, then you would have a value of, well, 1, 1, but you'd have to convert this into a unit vector, so it'd be around, I don't know, 0.7 something or something. Now, the good news is that the BlenderBIM add-on lets you calculate this. So if you go into the world settings, turn on under sun position, and if you just go in, if I can show north here, so this dotted blue line shows where north is. So let's say north is actually here, where we had our example. So I should roughly see, if I made that negative 45 degrees, I should get exactly the number, well, the unitized vector of this. And so if I do that, and if I press this get north offset, you can see that it has worked it out for me and filled out those values correctly. But again, you should not be typing any of these values in manually. This just gives you an idea of what they are, how they are stored. The scale factor would be something that somebody would tell you, let's say, I don't know, 0.97. But this is an example of a fully filled out geolocated file. And now all I need to do is export it out. And if I go in there, you will see I have two pieces of information here, IFC projected CRS and IFC map conversion, which store all of that information in the IFC file. What I've shown here is an IFC4. In IFC 2x3, this is not possible, so you will uncheck this has georeferencing, and the place to store it is in a property set assigned to the site object. So you go over to your site object, and you'd add a new property set, and there is a convention established of a property set called EP set. I guess that means extra or extended property set, map conversion, and projected CRS. So just add them, and then exact same concept, just that now it's stored in a property set. So, okay, that's it. I was going really fast there, but does that, hopefully that made some sense, and that's how you georeference your IFC files.
Yeah, but is there, like, for example, a very clearer and simpler way to show this? Like, for example, do you have a 3D model that you can just open, or IFC file you had before, right? Let's just take one random 3D model you have, and how just very, very quickly do the same.
It would be exactly the same thing. I would go
need to go through the same settings, right? But usually, I never had something to do with this with these numbers, with these eastings and northings. So that is provided by the GIS team or by the surveyors.
By the surveyor, correct. And so what those eastings and northings, they represent the location of that 000 point.
Mm-hmm. Okay.
So when that, if you just translate this by the eastings and northings, that will get you to where you are on the globe.
Okay. Is that valid for every country, right? That system is valid for it's global, right?
Correct. But why I described all the complexity at the beginning is to realize that although where are we? Where's georeferencing? Although these things are similar concepts, that you have an X and Y and Z and a rotation and a scale, it's also important to note the various international standard which is used for projections and datums, and also what unit it's stored in.
Mm-hmm. Yeah.
So for example, if you put your eastings and northings and in millimeters, because you're working in millimeters, but actually your reference system is working in meters, that could be a mistake.
Okay. Yeah. Okay. Thanks. If somebody wants to ask something, please just click on the hand and yeah, go ahead. Duncan?
Yeah, hi, Dion. I'm just wondering, so often, hopefully, the landscape architects or one of the disciplines would have sorted out all of these settings. Is there a way of copying them, or do you have to manually take these things and write them into each separate discipline model?
Currently, and this is not specific to georeferencing at all, you have to copy and paste into each individual IFC file. And the reason why I say it's not specific is because you have the exact same problem with things like building story RLs, right? Everybody copies and pastes it and makes mistakes while they copy and paste it. Even things like project names, right? You can't just link it from one guy who's considered the authority at the moment. But the reason why you also shouldn't necessarily just copy paste blindly is because my 000 might be not the same as the landscape architect 000, and therefore you shouldn't just copy paste this. You'd go back to the surveyor and say, hey, just double check this for me. Here's my 000 relative to site boundary or whatever, or map grid intersection. Please tell me what these values should be.
Yeah. Does anybody else wants to ask something? Let's see, I see a comment here. Cyril? Do you have any questions? Same in Switzerland.
No, it's pretty clear. I was just mentioning how it is locally.
Yeah, that's right. The example I gave here is Australia, but everybody will have their own local codes that they're familiar with. But it is worthwhile to look it up in the EPSG database so that you also know the number, because that's the standardized way, so that later on you don't just have some people type in GDA 94/MGA 56 and somebody types in zone 56 and somebody types in MGA 56 with no space, and you can't work like that, and that's where the putting in the EPSG number comes in.
Yeah.
One more thing I briefly wanted to mention, which I've lost here because I've lost my site. Let's just do a quick project setup here. The site can store ref latitude, longitude, and the ref elevation. This one you do store in latitude, longitude, elevation, but keep in mind that, of course, this is not how you should properly georeference your model. This is only used as a reference. So your site may be, somewhere out here. It's not necessarily the same as your origin, and that's why I drew this arrow thing here. So this ref latitude, longitude, and all that refers to this point here, whereas this georeferencing refers to this point here.
Yeah. Torsten Long would like to ask you a question. Yeah, please go ahead.
Well, you just explained, what is if your origin doesn't correspond with your survey point.
Yeah, it's not, no such thing as a survey point really in IFC, and I think this is a misconception that, well, yeah. What you'd have is just places and arbitrary points in your local system and a way of translating that back to your global system. Obviously, in real life, you would have many survey points. I mean, you probably need at least 2 to work out the transformation from local to global. But in reality, you'd have many survey points so that you can get average out the errors of the local to global transformation. But there isn't such thing as one survey point in IFC, and that reflects reality in how the world works. There isn't one survey point in reality either. There are many survey points. So IFC simply calculates where you are from this 0, 0, 0.
Yeah. Duncan, please go ahead.
Yeah, maybe you have shown it, but I didn't notice. How do we set the rotation of our project?
So the underlying method to record a rotation is by entering these 2 values here, the x-axis abscissa and x-axis ordinate. And this can be really unintuitive because we usually think of the rotation to true north as an angle, not a vector. But effectively, this is a vector. And even more confusingly, it actually is not a vector pointing north. It's a vector pointing basically east. So if this is where north actually is, so I'm in my local space, and this is where north actually is, the value I'd put here is this vector here. I know it's pretty unintuitive. It does make the math a bit easier under the hood, and maybe that's why it's stored that way. I'd really like to know, actually.
So what does that look like? What does that look like when you fill that field in?
So, for example, and the easiest way to do this is, well, if I fill that in manually, I could type in, where it is, basically 1, 1. If this was 45 degrees, right, this would be a vector of 1, 1. So that's how I would fill it in. Now, that can be a little bit confusing. So in Blender, there's a way to derive it from your Blender's north. So Blender has a way to set the north, which comes in out of the box. You just basically say where your north is. So if I put my north around here, you can see that if I go back here and if I press set the north, get the north offset. I shouldn't have pressed that. So if I press get the north offset, it works out that vector for you.
Brilliant. How nice that somebody coded that in.
Yeah, but I thought I wouldn't hide this. And the reason I'm also explaining it is because ArchiCAD, for example, does not have this button you can press. You actually need to work it out and type it in yourself. And I think, is it the same in Tekla? Or I could be confused. Maybe not Tekla, but definitely from memory, ArchiCAD has this issue.
Yeah.
But I mean, once you have all of them laid out, so let's say I make my eastings, so let's say 10, 20, 30, I can convert from local to global and vice versa. So the way this works is it actually it checks where your 3D cursor is. So my 3D cursor is currently set at 0, 0, 0. If I press this button, convert local to global, you can see it has moved the 3D cursor to 10, 20, 30. Mm-hmm. And that's it doing that. In this case, it's a very simple translation. The scale, if you leave it blank, it defaults to 1. But let me just say it's usually not 1. Mm-hmm. It will also spit out the value in the console, simply because, let's say, because Blender wasn't built for global coordinates, and in general, that's the reason why we need these conversions, is simply because computers don't really work if you just set 0 and just keep on going out for kilometers and kilometers. The computers get upset.
Yeah. Let me ask you a very dumb question. Why is geolocation important?
Well, the first issue is because you can put your building in the wrong spot. Right?
Oh, really?
Yeah, correct. I mean, the first issue is not so much your responsibility, because most of us here are not surveyors, I would imagine. But the first issue is us knowing to ask the question to make sure it has been considered by somebody who does know what they're doing on the project, because somebody out there in the project needs to consider it, especially on a large project. They need to consider it, and it's our job just to be mindful that somebody out there has considered it. And the second issue is our job to be neat with our data to store the relevant information so that next time somebody picks up the file or it gets passed on to the next project, somebody can readily see all of the parameters that have been used. So for example, right now, well, not right now, but earlier this year, Australia switched over to a new coordinate reference system. And the previous one was locked in the year 1994. And so we've had 26 years of generally not thinking too much about this. But now we're going to say, for all of these projects, which system is it using? Is it using the one back in 1994, or is it using the new one? And it's kind of ambiguous around this point. So it's important to record all that information.
Yeah, good. Thank you very much. I think it's a wrap. If there are no other questions, we can wrap it up. Oh, Cyril, yeah, go ahead.
Yes. In Blender, how is it possible to have when you have set up all this after, can you see coordinates of the points
In
elsewhere?
global?
Yes.
At the moment, you actually have to pick a point and you press this button or the opposite button. It's painful.
So let's say, yeah, because when we have external pipes in the ground, often we need to put coordinates and altimetry. And so I was curious if there is already a way to do it in Blender.
You mean like annotate it?
Yes.
Yeah. Currently, no. That would be pretty simple to code, so it should be something we should add. Yeah. You do bring up an important point, which is bringing in external files, special civil files, to mix with the local coordinate system that you're currently using. Often those files will not, especially civil files, will simply not have this georeferencing set. They'll be fully in absolute coordinates of eastings and northings. And so for that to bring it into your system, you'd often need to patch that file in some way to offset it to where you are. And there are various, here you go, here's the default one, reset absolute coordinates. There's a few ways to do that with the IFC patch tool, but maybe that's getting a little advanced. We'll cover that another day. But just to annotate the points, no, there is no current tool which does that, but there should be. There absolutely should be. I don't see why not.
Especially if you say that the implementation is not very complicated.
Correct. The implementation is fairly simple. Yeah.
Cool.
Thanks.
You're welcome. Anybody else? Or are we going to sing Jingle Bells now?
Christmas break. Oh, looking forward to it.
Yeah, well, thank you very much, Dion, and everybody. And yes, I wish you a Merry Christmas. And no, it's too early for a Happy New Year because we are going online next week as well. So yes, stay tuned. Have a good one.
Cheers. Have a good one.
Thanks very much. Bye, guys.